Everybody, it's Mrs. Cassill, and welcome to your Gravity Lab. Full disclosure, I've played this a lot, and it's super fun. I'm not putting my face in here because essentially I'm just going to narrate what is on the screen. This will serve as your tutorial for how to do this particular lab, as well as provide some support and the background information for those of you who may get distracted like I have many times and just click your way through the fun parts. So here we go, gravity. How do celestial bodies warp the fabric of space-time and interact with each other? Create an object to begin exploring. I'm going to click Create Your Universe. All right, press and hold to create an object. Here we go. Okay, I'm going to click and hold until I like this. Okay, that's good. That's nice and big. Ooh, press, hold, and flick to add velocity. And they give you a little suggestion here, like press and click and flick it this way. Oh, it worked. Oh. See how the colors match? Notice how the colors match? Oh, and as time goes by, you'll see an orbital path is marked out. I was successful. Look at what I made here. Oh, it looks so beautiful. It's a little solar system. I'm going to do some more. Okay, here we go. Two celestial bodies of different masses have distinct effects upon spacetime. A massive object creates a greater distortion of spacetime, and something else that I couldn't read that, I'll go back and read afterwards. So here I've got two totally different orbits. This is great. You know what I really want to do is try to create a moon for one of them, but I know that I will fail. So I'm going to try. We're going to see what happens here. So, oh, oh, oh dear. Oh, I didn't give it enough velocity. Oh, this is bad. See how the colors don't match? According to Newton, the larger the mass of objects and the shorter the distance between them, the stronger the attraction. That is absolutely true physics. Let's try it again. I'm going to see if I can. Oh, what's big? Gravity penetrates everything and holds the galaxy together. Oh, look, it started moving my main mass. Oh, come back. I don't want it to do that. I'm going to put a big thing over here. See what happens. Oh my gosh, you guys, it's bad. You've created a binary system. These two celestial bodies weave around their common center of mass. This is rad. I'm going to click record, and it's going to record a little GIF of my soup. Objects move proportionally to their mass. Tiny planets move great distances. Massive planets may only wobble. This is really exciting. So up here, you guys, when you click share your universe, it'll open up for you this little GIF of your solar system you've made. So if you click the download button right here, I'm on a real computer, so it's going to download it to my, hard drive. But how come it's not doing it right now? Maybe because I'm recording. Okay, well, so something's not working. But anyway, you can record this, or I can right click. Oh no, that's what it is. You right click on it, and you can save the image because it's a GIF you'll see right here. So this is the thing that you're going to save because that's what you want to upload. So you're going to need to name it something smart, like my solar system, STEM, physics, with your name on it, J. Cassill, like that, and save it in a place that makes sense. So I'll put it in STEM physics right there. Okay. All right, that's what you had to do. You had to right click on the GIF to make that work. Okay, I'm going to close this. Click the close button. I'm going to keep playing. I'm going to see if I can make a moon for one of these, or what happens when oh, zip. Communication satellites aren't the only man-made objects orbiting Earth. Astronauts have left tools, gloves, and other space junk that might still be floating around. Cool. Wow. My system's so fast. Whoa. Oh, that's rad. When slow-moving celestial bodies collide, they might fuse together and enlarge, increasing from a few kilometers to a few hundred kilometers in diameter. I'm going to put some other stuff over here. Oh, look, this is far enough away, and its mass is small enough that the gravitational pull between these two things is so much stronger than this that it essentially has no effect. I'm going to see if I can make a little mini solar system here and see what happens. Typically, comets have elliptical orbits. These dirty snowballs come from the outer edge of the solar system, pass near the sun, melt, produce a long tail, return to the edge. I figured I had to read pretty fast to keep up. Okay, so this is pretty cool. Let's see. see if I can like see if one of these will pick up this little thing. It won't. Interesting. I thought for sure they would. Oh, but see how they show what they're bending space-time? Everything in the universe, moons, planets, particles, even light is drawn towards everything else because of the force of gravity. So I had to create some. Oh, it blew up my solar system. During the early days of our solar system, there were lots of collisions. The scattered debris mostly formed back together or attached to planets. Well, now this is just one lonely little green thing over here. See if I can get these two things doing something interesting. Oh, they blew up. Don't worry, nowadays our solar system is stable and planets are unlikely to collide. However, you still need to watch for dangerous asteroids. My binary system is so rad, you guys. Alright, I'm going to try to just feed this one until it gets super big. Earth-like planets begin as particles formed from collisions of gas and dust and grow by accretion. A mature planet can take thousands or even millions of years to form. Yeah, I'm going to make that yellow one really big. Oh, I missed. Alright, let's make it really big right here. Oh, see the bending of the space? Oh, I destroyed it. Oh, shoot. Oh, no. What's in here? Your universe has reached critical mass and collapsed. Fascinating. That's awesome. So, uh, this is really cool. I'm going to do this again. So, go ahead. So first, last time I managed to create a binary system. This time I'm going to try to create something that just see how it's bending that space-time. So essentially that curve is there and it's invisible at all points in time. And things are actually just traveling in straight lines around that curved surface. If you've ever been, a lot of bus stations or subway stations or airports have those uh, coin donation things that are big, huge funnels. So you can roll your coin down it and it'll go around and around and around. That coin, you roll it in a straight line. It's just following the curved surface, which creates circular motion. So the same thing is essentially happening with gravity. So there we go. We've got a stable little solar system. Ooh, I got two. Orbiting objects zip towards a gravitational center and then slow when pulling away. This is one of Kepler's laws. So you'll see that some things are, look at this one, it's slower over here and then it speeds up and then it's going pretty fast, but watch, it actually slows down as it approaches this furthest spot. I'm going to see if I can do that too. I think I got a good one. An orbit system is a gravitationally bound collection of celestial bodies. Look at it. I got some big, crazy elliptical orbit. Look how slow it is over here. But watch as it gets closer to the center of my solar system. Oh, never mind. Oh, dear. Mars has been shaped by impact. Its northern half is smooth and low. The southern half is mountains and rough. So it's different, like the two different planets. Okay, well, that's pretty cool. All right. I'm going to restart my solar system, but I have a feeling that it's going to leave me. The sun is the center of planetary orbit in our solar system, but each planet has its own gravitational field, and most have their own natural satellites. How far out can I zoom? Okay, that's pretty good. Oh, how big can I make this thing? Okay, let's throw it. Oh no. Oh, I broke it again. I broke it. Okay, everybody, that was super fun. I'm going to do one more, and this super long video. It's a tutorial. So here's the point. As you try this, I want you to try to create a stable solar system that has at least 3 bodies in it. You can make them big, you can make them small, you can make them orbit, you can make them crazy elliptical if you want. Oh yeah, that one was going too fast and too far to make it in. Oh. Oh, that one's gonna maybe make it. It changed color. Oh, shoot. Okay, I blew up my solar system. Oh, that's bad. Okay. Oh my gosh, I got 2 orbiting in different directions. Oh, that's really stressful. Okay. Oh, bye, solar system. Goodbye. So your goal is to create a stable solar system with at least 3 objects in it. So that might be the center and 2 orbiting bodies. It might be a binary system with one other orbit, like I showed you on my first run through here. You can absolutely try more. You can try to get something with a moon. It's entirely up to you. I want you to play and have fun with this. The one that you think is the coolest, that's the one that I think you should record and share, because it's just really fun. So, ooh, let's see if I can get one more. Oh, I think it's got to go really fast to be this far out. Runaway planet. That object's velocity is faster than any nearby gravitational force. Okay. Oh, that one almost made it. Oh, not quite. Maybe it has to be really little. How fast does a rocket need to travel to leave Earth? Any projectile must reach a speed of 7 miles per second to break free of our planet's gravity. So cool, you guys. Okay, so the things to observe while you're doing this. Let's start over. I want you to be able to observe, where have you put mass in your solar system? Where have you put mass? So be able to comment on, here I have a large mass, here I have a small mass. One is stably orbiting, and that's because it's traveling with enough velocity to go around. So where's the mass? The biggest mass is holding any other orbits I may or may not create together. Go too fast. Oh, maybe that one's gonna go. See if we can get one right here. Ooh, I got a little one right in the middle. Okay. I want you to be able to pay attention to distance. The two things that affect gravity, the force of gravity, are mass of the bodies in question and the distance between them. We use r for radius for this, um, because as you see, an orbit is in general a circular or elliptical shape. So pay attention to how far apart things are, how big they are, how fast you had to make them go, what kind of shapes you get. Those are the things that you can sum up in your discussion question here. So you created a solar system. It must include at least 3 objects, achieve stable orbit, record it and upload that GIF, comment on it, where you sort of comment on, how do celestial bodies warp the fabric of space-time? Ooh, okay, so I could say a little more about that. So the big object here has so much mass that it is bending space-time in around it, creating a curved surface for these smaller masses to follow. And that extends all the way out through space. It's strongest, there's the most curvature of space-time nearest the object in the middle. There's the least curvature further away, which is why things, even though you might try really far away, it's really difficult to get them to orbit because, ooh, this one attained escape velocity. So, um, yeah, so anyway, so those are the things to comment on. Those are the sorts of things you can include in your answer. And otherwise, have fun, you guys. I sure had fun.